Today we're going to talk about a concept called residuals and also finding another best fit line by a different calculation. So a residual is basically the difference between the actual data value and the value calculated by the best fit line. So over on the left we have a bunch of data and a best fit line that was calculated. Now to the right we have the residual values. A residual is calculated by taking the difference from a point to the line and graphing how far away from that line is that point. Now this appears to be somewhere around 41 and this is somewhere around 44 plus. It's a difference of about 2-ish. So you'll see this point is indicated by a residual value of 2 away from the best fit line. All right. Now let's look at a point on that line. If we look at that point as almost on that line or very little away from that line, this is its residual point. In other words, it has a difference away from that calculated line of almost 0. Now, if the best fit line is a good fit, then the residuals are going to be very close to 0. And typically there's going to be no pattern in the residual plot. In other words, things will be equally spread out above and below the residual line or the line of 0, which it is in this picture. So let's go ahead and see how to calculate some of this stuff using our calculator. So once again, you're going to have to get that out. So here I have a set of data talking about years versus the percentage of 7th grade kids that meet all 6 physical standards set forth by the state of California. And you notice just by looking at the data here that it appears that kids seem to be doing better as years have gone by. They're getting in better shape. What we're going to do is we're going to use our calculator to find the least squares line or the best fit line and then graph a residual plot using our calculator. We did the regression line yesterday, but let's do it again just for practice. So we turn on our calculator, we go to Stat, followed by Edit, and in Edit, in L1, we're going to input the following numbers. In L2, we'll input the following percentage numbers. So why don't you go ahead and do that. Once that's done, we'll take and calculate our regression equation. So we're going to quit out of here. Again, you can pause in between all these steps if you need to and rewind as much as you need to. We'll hit Stat, Calculate, and linreg once again, 4, hit enter, and we have a calculated value of 3.14 for M and negative 6,257 for B. So I'm going to go ahead and write that equation on my page. Y equals, that was 3.14x minus, need to go look at that number again, 6,254 for y, 6,254 for y, and that's going to be my regression equation. If I wanted to plot that, once again, I'm going to need to look at my window. And I'm going to want to see values from basically 2000 to 2010. So I'll set my X window at 2000 minimally, my X max at 2010. And I'm going to need to see percentages at least up to 40%. So I'll go from 0 to 50 for my Y. If I graph that, there's my plot. And now I want to take and also put my calculated best fit line in here. So remember again, we go to Y equals, vars, we go down to statistics, move over to equation, and hit reg equation. That plugs that into the calculator. We hit graph again and we see our best fit line. Now, we can't calculate the difference between our data points and our line points. I would imagine we could, but it would be painful to do so. So we're going to have our calculator actually do that graph for us and do a residual plot for us. So here's what we're going to do in order to do that. We're going to go up to stat plot again. And at this point, we know we have our stat plot on, and that enabled us to graph this best fit line, as you can see over here to the right that I'm indicating with my cursor. And we're going to actually turn that off now. So you hit enter, move over to off, and then we're going to go back to stat plot, and you'll notice now that stat plot is off. We're going to actually turn the second stat plot on. So we go here and change it from off to on, and you'll notice down in X list we have L1, but we have something different in our Y list. I've already put that in there. If you don't have this in here, here's what you're going to do. You're going to move down to Y list, hit stat after you've hit second. So we're going to go second, stat, and if you look now, number 7 has residual. So we're going to put that right there. So what we're going to do now is, since we've already calculated our regression line, the calculator stored that in its memory, and in the Y list, it's going to calculate all the differences between that regression line and the data points, and then plot that. So now what we're going to see is we're going to see how far away from the data line are those points. We're going to have to change our window because our window right now is set for 2000s, and what we've seen is that these points here are going to be very close to that line. So I want to look over the course of these same years from 2000 to 2010, but my Y differences are going to be both positive and negative. So I'm going to go from, let's say, negative 6 to positive 6. And I'm going to look at my residual line calculation. So here's my residual calculation. I have some points above, as we can see here, and some points below, which we can also see. And it varies between, well, since all these are 1s, a high of 5 and a low of, negative 5 away from that line. And we can see it's evenly spaced, so it's not a bad set of calculations. All right. And once again, we can take a look, and I've done a screenshot of that, and here's our residual plot based on that calculation. All right. So once again, work with that calculator, understand how to maneuver around it, and get these two graphs. And if you have to watch it again, so be it. Next thing we're going to do is we're going to calculate a different best fit line, and this is going to be called a median fit line. And it's just another form of a best fit line, but it uses not all the data. It uses medians of data, which means midpoints of certain sets of data. And they'll tell you what you want to calculate, and you press the following buttons accordingly. So let's go ahead and do a median fit line for this set of data. And here's the data I need. So we're going to go back to our calculator. We're going to go back to stat plot. We're going to turn the second stat plot off because that's calculating our residuals. We'll go up to stat plot again and turn our first stat plot on. And this is going to give us a scatter plot where my first X's are going to be in L1 and my Y's are going to be in L2. And then we're going to plug in the data once again. So we're going to hit stat, edit, and we're going to plug in the data on this main screen. So here we go. Pop in these numbers. So now we have all these numbers plugged in, our years being in L1 and our values being in L2, and we're going to calculate our best fit line again. But in this case, what we're going to do is we're going to take and calculate. Remember, hit stat, move over to calculate, and notice right here number 3 is median line. And we will get an equation once again. It's still going to be y equals mx plus b, except you'll notice we don't have an r value here because r talks about a least squares regression line. So in this case, what we want to do is we want to write this formula down. So it's y equals 1766 x, and then our y-intercept will be, wow, negative 3481866, negative 3481866, and that's our median line. We're going to do an extrapolation of this in a minute at 2015, but in order to do that, we have to go ahead and graph this on the calculator. So if I hit graph, you'll see that we have nothing here, which means that my window is probably off. So I'm going to look, and sure enough, I have values from 2000 to 2010, which makes sense. That should be everything I need to see. I'm going to make it actually go a little bit bigger since 2010 is my last number. So I'm going to go over here, and we'll make this 2015. But you'll notice our y min and y max is 6 and negative 6. Now, taking a look at what my y values are, they go from 60,000 to 70,000. All right. So in order to see those, I'm going to actually need to increase those y values quite a bit. So in this case, what I'll do is I'll take and make my y min 50,000. And I'll make my y max, let's go to 80,000. And that way I guarantee that I'll see everything in my graph. So if I go ahead and graph once again, there's my line, or my scatter plot, if you will. Now if I want my line, all I have to do is hit y equals. We go through the same things we've gone through previously. I'm going to clear my previous line that I had in there from our previous example, and go vars, stats, equation, regression equation, and there's our new equation of our median line, which is over to the right over here. Hit graph once again, and we'll get a line that once again splits those. And if we want to do an extrapolation and find out, well, where is this value going to be at 2015, we go to table, so second graph, and we want to know what's happening at 2015. And at 2015, I get a total of 77,967 at 2015. So I've done my calculation of my median line and then an extrapolated value at 2015. So that's just another best fit line. What I'd like you to do is do your lesson summary. The question asks you to find a median fit line, so that's a median line, and then do an extrapolation at 15 seconds. See you tomorrow.